SI unit of length. SI unit of length is meter, represented by small m. A meter was originally defined in 1889 as the distance between two marks drawn on platinum and iridium alloy. That means an alloy with 90% platinum and 10% iridium, kept at 0 degree in the International Bureau of Weights and Measures at Seviers near Paris. Later on in 1983, the meter was redefined in terms of speed of light, according to which 1 meter is the distance travelled by light in 1 divided by 29 crore 97 lakh 92,458 of a second in air or vacuum. Then subunits of meter are centimeter. 1 centimeter is the 100th part of meter, that means 1 by 100, that means 10 to the power of minus 2 meter. Next, millimeter, mm. 1 millimeter is 1,000th part, that means 10 to the power of minus 3 meter. Micrometer or micron is the 1 millionth part of a meter, that means 10 to the power of minus 6 meter. Nanometer is 1 by 1 millionth part, that means 10 to the power of minus 9 meter. Then multiple units of meter are kilometer. 1 kilometer is equal to 1000 meter. Non-metric units of length are bigger units. They measured in astronomical unit. 1 astronomical unit is equal to the mean distance between the earth and sun, that means 1.496 into 10 to the power of 11 meter. Next, light year. 1 light year is the distance travelled by light in vacuum in 1 year, that means is equal to 9.46 into 10 to the power of 15 or 9.46 into 10 to the power of 12 kilometer. Next, parsec. 1 parsec is the distance from where the semi-major axis of our orbit of earth subtends an angle of 1 second, that means 3.26 light year. And next is angstrom, smaller units, that means 10 to the power of minus 10th part of meter. 1 nanometer is equal to 10 angstrom or 1 micron is equal to 10,000 angstrom. Nowadays angstrom is outdated and nanometer is preferred over. Next is Fermi. Fermi means 10 to the power of minus 15th meter, means 1 divided by after 1 15 zeros. That means 1 Fermi is equal to 10 to the power of minus 15 meter. Next we'll move on to unit of mass. SI unit of mass is kilogram, represented by kg. In 1889, 1 kilogram was defined as the mass of cylinder piece of platinum, again iridium alloy, kept at International Bureau of Weights and Measures at Seviers near Paris. Subunits of kilogram are gram and milligram. 1 gram is the 1000 part of a kilogram, that means 1 kg is equal to 1000 gram. Milligram is 1 millionth part of a kilogram, or it is 1000 part of a gram. 1 milligram is equal to 10 to the power of minus 6, that means 1 divided by 1000 after 1 6 zeros kg. Next, multiple units of kilogram. These are the bigger common units of mass used in our daily life, that is quintal and metric ton. 1 quintal is equal to 1000 kg. Metric ton is 1 metric ton is equal to 1000 kg, that is equal to 10 quintal. Non-metric units of mass is as atomic mass unit, that means AMU. Here 1 AMU is the 1 by 12th the mass of 1 carbon 12 atom. That means here 1.66 into 10 to the power of minus 27 kg. The mass of largely heaven bodies is measured in terms of solar mass. That means 1 solar mass is equal to 2 into 10 to the power of 30 kgs. Next we'll move on to unit of time. SI unit of time is second, represented by small letter s. A second is defined as 1 by 86,400th part of a mean solar day. Here you can say 1 second is equal to 1 by 86,000 into 1 mean solar day. 1 solar day is a time taken by the earth to complete 1 rotation on its own axis. That means 1 year 1900, that means it comes to 3,155,6,926.08 seconds. 1 second is a time interval which I told you 91 crore 92 lakh something 9192631,770 vibrations of radiation. Smaller units of time is millisecond and microsecond and nanosecond. 1 millisecond is 10 to the power of minus 3 second. Micro means 10 to the power of minus 6 second. Nano means 10 to the power of minus 9 second. Bigger units of time is minute. Hour, 1 minute is equal to 60 seconds. Then 1 hour is equal to 3600 seconds. 1 day is equal to 86,400 seconds. Lunar month The Western or Gregorian calendar is based on the period of revolution of the earth, but our Hindu and Muslim calendars are based on the phases of moon as seen from the earth. These calendar, 1 month is the time of one lunar cycle, which is nearly equal to 29.5 days. The period of 12 lunar months is 354.37 days. Next, when we talk about month is here, it has a like January, February, January, March, May, July, August, October and December has 31 days. April, June, September and November each has 30 days, and February has 28 days, but it comes for leap year 29 days. Next year, 1 year is defined as a time in which the earth completes one revolution around the sun. That means 1 year has 365 days. That means 3.1536 into 10 to the power of 7 seconds. Next, leap year. A leap year is a year in which the month of February has a 29 days. That means on that particular year, which leap year has, instead of 365 days, it will come to 366 days. Next, decades. Decades is nothing but 10 years. One decade is equal to 10 years. That means 3.1536 into 10 to the power of 8. That means after 3.1536, 8 zeros you have to add. Next is century. Century is 100 years. In century there will be 24 years, each of 365 days and 76 years. That will come to 3.16 into 10 to the power of 9 seconds. Next is millennium. A millennium is of 1000 years. That means 3.16 into 10 to the power of 10 seconds. Here, what are the guidelines we need to follow to write the units? Number 1, the symbols for a unit which is not named after the scientist can be written in the small letter. For example, if you are writing meter, you should write small m to represent meter. Second, small s, kg, small k and g. Like that, the symbol for which named after the scientist should be written with first capital letter. For example, you are writing Newton, it should be N should be capital. You are writing Joule, it should be J capital. Watt, W capital. Pascal, P should be capital, A small. Hertz, H capital, Z small. Coulomb, C should be capital. Volt, V should be capital. Although liter, the unit of volume, is not named after the scientist, sometimes we write L capital instead of small l. So avoid confusion between the letter L and sometimes L capital will be used. The full name of a unit, irrespective of the fact whether it is named after the scientist or not, it should be always written in a lower initial. For example, the mass is written kilogram, not as K capital and rest other small. Like that, unit of length is written as a meter, not as M capital meter. Unit should be written as small m TRE. It should not be M capital ETRE. Like that, if you are writing with Newton, N should be always capital. Next, number 4. A compound unit formed by the multiplication of any two units. That means derived units, when you are writing, it should be here, the unit should be written again for scientist, named after the scientist like Newton, Pascal, should be capital always. Here, negative power is used for the derived unit which is formed. For example, the unit of velocity, if we write, or area we write meter into meter, you can write meter square. If you are taking into force into distance, Newton meter, Newton should be capital N and M should be small. Next, number 6. A unit in its short form is never written in the plurals. For example, you are writing 10 meters. Already meter is a plural. You cannot write meters and add s. It should be 10 meter only, METRE. Number 7. To avoid powers, we have to have a prefixes. When prefixes are used, symbol should be used combined way.